Okay, howdy. Nice to meet you. And today it is the last time for doing statistics. And also next week in the Tuesday, we will have an exam too, right? And at this time, you have two options. One is just using Anorak, and the other one is just choosing the, kind of traditional Zoom proctoring. So I will just explain it in the class, and also I explain it in the email so that you can choose it. So first thing, if you choose use Anorak, actually Anorak is just some kind of software. Then what you can do is actually when you just, what you need to do is just sit in your computer at the time 1:30 and then just log into eCampus without any instruction. Then you can see the exam 2, then just click exam 2 and follow the instruction from the eCampus, then you're okay. So it will instruct you like just take your picture of turn on your webcam and just do 360-degree turn on with your webcam and just take your ID, picturing your ID and so on. So actually, yeah, it is not that bad. So because all the instructions are just given automatically and all of your actions are actually recorded on a rack and it will figure out whether you cheat or not. So in that case, you don't need me to be proctoring, right? But I know that actually it was tested for other classes, and there are some concerns that actually when we use the Zoom, we also record your actions in the Zoom, right? But in case Anurag is actually not from the university, but is from some companies, so some of the students actually worrying about their privacy, because their recordings are actually transmitted to the company, not the university. So in that case, if you're worrying about this kind of privacy thing, or if you are not just, not comfortable with this kind of, AI proctoring, it's like kind of dystopia things. But if you don't like such a, AI proctoring, then you can just use the traditional Zoom proctoring. So in that case, I will, as usual, I will just make a room from 150. And usually, as we did in the last time, I just check your ID and papers and your calculators in manually, then do the same thing as we did in the last time, right? So you have two options, but because I need a proctor, another proctor to, if you or a lot of you choose the way two. So if in case if you just choose the second way, then please email me until this Friday, right? So that I will write down an email in the game, but just please email me until this Friday. Okay, question? Yeah, in that case option, you need to choose number two. Then what it means that you need to log in at that point, and you need to also log in into the Zoom. Yes. So yeah, in the second option, I definitely give you the option for WebAssign because someone actually, including me, do not compare with the eCampus, so you can use WebAssign. And next question. Yes, in case of the second option, you need second device. But in case of using Anorak, then you don't need a second device. What only need in case of one, so I'll clarify this. You only need one device.
Could you share your screen?
Oh, sorry.
No problem, thank you.
I think I shared it, sorry. Thank you. Yes, can you see it?
Yes, thanks.
Thank you. So in case of use Anorak, then all you need is one device, which is just laptop and webcam. But in case of use second option, then you need two devices. Yeah, as usual for laptop for taking your exam, and cell phone or any other camera for logging to Zoom, right? So, for taking exam, cell phone for Zoom. So yeah, and so in case of, in second option, you can choose either eCampus or either WebAssign. And as we did in the last time, you can just submit everything on the eCampus or WebAssign, then just send the, worker path to me via email, then you're okay. But in case of you using Anorak, then you need to write down everything in the, eCampus. Then you need to also upload it to the Anorak browser. Actually, they support such a upload things, so you can just upload your worker part, then you're okay, right? Okay, do you have a question? So it will be opening on 1:30, but actually to provide cheats, so to prohibit the cheating, so I just give it some kind of window. So it will be talked with my advisor, my course coordinator, but usually it will be 4 hours or 6 hours between them. So I will let you know. So what her question is that in case of use Anorak, that there is some time window, there will be some time window. Yeah, so from usually 4 hours, but I need to, I'm also just, I'm just minor teacher, so I need to get approval from my course coordinator that which hours we need to use. Okay, okay. Oh, thank you. That's good toss. Okay, Paula says that will the format of the test will be like the, he or she, okay, sorry. Yeah. Yeah, your net ID is okay, but if you have driver license ID, it's okay. It is also okay. Yeah. Yeah, then it's okay. Yeah, no problem. Yes, if you have driver license, then you're okay. You. Uh-huh. Uh-huh. Yes, in that case, please email me. Then I will just tell the Anurag that you have such a situation. So I will take it. Yeah, great. Okay, Kim. So what Abby says that if you don't have such an ID right now, then Student Service Center gives you some kind of printout, then you can use it as your ID. Great, thank you. Oh my gosh, he lost his ID 5 times. Okay, so Paula asked me that will the format of the test be like the last time, multiple choice, TF, and short answer? So there is only 1 or 2 TFs, and almost always actually short answers, and multiple choices are actually also on 20% maybe. So yeah, I will count it and let you know in the email detail, but what I'm just remembering is that TF maybe just 1 or 2 programs, and multiple choices are also 15% or 20% of the whole portion. I'm not sure right now, but yeah. And almost all is just short answers. And there are 2 workup programs. If my memory is correct, then these are all, but I will count it and let you know in the announcement email that which portions are taking, right? Okay, then is there any other question or exam? Pardon? Yes. In the exam, there are 19 questions in the exam, but each question may have some, sub questions. So if you just include sub questions, then it will be 25. But yeah, total 90. Okay, your question? Oh yes. So at this time, because in case of using Honora, then you can use your whiteboard or you can use your scratch paper. So yeah, you don't need whiteboard when you use the Honora, but in case you use the Zoom proctoring, then as we did, you need whiteboard, right? Well, any page protector, right? And there is another question that, so we have to email you which options we want to for the exam. Yeah, especially if you just choose the option 2, then please email me before, until this Friday, which means that this Friday night. So, okay, just 11:59 p.m. Because, I need to get some another proctor. If you, maybe all of you choose the second option, then I definitely need another, proctor, which will help me. So in that case, please let me know before Friday, 11:59 p.m. if you choose the second option. But if you choose the first option, then you don't need to email me. Okay? Okay. Yes, Q6 is due tonight. So it is about taking video, about investigating a poll and judging that whether this poll is just good or not, or it has sample bias or not. So it is just also until midnight. No problem. Yes, for only 2. What I mean, yeah. So in the last time when you do the video, when you do just 2 videos, then I will give you extra credit, right, for the quiz. So at this time, actually I think that maybe you remember that quiz 4 is the bonus points for exam 1, right? But not much of you actually did for quiz 4, and also some of you didn't get the full credit for quiz 4. So for your encouragement, so I will at this point if you just do one extra pour instead of this quiz, then I will give you 2 points on exam 1. So technically, you can get 107 points on exam 1 out of the 100, so including quiz 4. So that's my extra thing. Yes, it's okay. If you do 2 pours, then it exceeds 5 minutes, then that's okay, right? But if you just 1 pour, but it exceeds 5 minutes, then please do not do this because I also need to have time for doing grading. So yeah, okay. Okay, do you have any other question? Great. So then let's deal with the last section 7 and 8. And if we have time, then we can do some review questions. So yeah, actually we did section 7, but I just wanna, remind you what we deal with in the section 7. So actually in this section, if you understand picture, then every problem is just so easy. It is nothing but just, doing formulation. But if you don't understand picture, then it is a little bit difficult to solve it. So I just wanna, explain it again. So what we wanna do is actually our goal for all this stuff is to find parameter maybe. Sometimes my P is not distinguishable with F, but anyway, so to find parameter, and parameter is nothing but some value or some, some number, just number describing population. So population is just the entire set we are concerned with. So, and especially in our course, the parameter is just nothing but number of portion having certain trait, right? So for example, maybe you're interested in the percent of smokers in Texas A&M, or maybe you're interested in the percent of voters who support, yeah, I don't want to be political, but just take Biden. Okay, or maybe you can interested in percent of voters who supports Trump also, right? So those are numbers that we are actually interested in to find. But as we said earlier, it is almost impossible to investigate all the population about this, right? So instead of doing this, what we do is just, obstruction is that impossible to investigate or in population, right? So instead, we can just make sample, right? So make sample is just choose people or choose element in the population randomly, right? Some part. So it is just part of population. Which is randomly chosen, right? So randomly chosen. So this is important assumption. So sample is just not only part of the population, but it is randomly chosen part of population, right? And investigate the portion, right? So in that case, it is called statistics, right? Parameter is some number describing population, and statistics, some number describing sample. And in our cases, both are maybe some kind of portion in the population or some portion in the sample, right? So for example, so here, these are example of the population. Then example of the sample is that maybe percent of smoker in randomly chosen 100 students in the Texas A&M. Or in case of to get the voters who support Biden or who support Trump, then this is percent of voters randomly chosen from registered voters of the United States who support Trump or Biden, right? Voters chosen randomly chosen, maybe 1,000, right? 1,000 registered voters of the United States who support Trump or Biden. So these are examples of samples, right? So does it make sense, or do you have any question on why we did this? Okay, right. Then now is a little bit kind of, out of box part. So now when you just get this kind of sample, then what statistician found is that actually getting sample is just equal to choose a point from normal distribution here. Normal distribution looks like this. So getting a sample is the same as choose a point from normal distribution, right? So especially getting statistics of sample. Sample is equal to just choosing a point from the normal distribution. So for example, when we say statistics, we always give some hat, right? P hat, and when we say about population parameter, then we say P. But this P hat, normal distribution with the mean P and standard deviation square root of P times 1 minus P over N, where N is just sample size. So that's what statisticians and mathematicians found, is that when you just do sampling and found some number from which percent of your sample actually supports Trump or Biden, then actually it is nothing but choosing some number from a normal distribution whose mean is the P, which is what you want to have. And standard deviation is also some number which is determined P and N, right? So that's what statistician found. So from here, but we know that it is the mean and standard deviation is determined by P, but we still don't know what the P is, right? So instead, so then you can thinking about that if we get P hat, so in case P hat is this statistics from the sample, then by 95% of probability, it would be in this interval, right? P minus 2 times square root of this standard deviation and P plus 2 times P, this standard deviation, right? Okay, I'll write it more clearly. Okay. Right, that's what we learned, right? Because if you're just thinking this number as a standard deviation, sigma, then it is nothing but what I say is that actually it is P minus 2 sigma and P plus 2 sigma. So if you just choose some number in this normal distribution, then by the 95% probability, your P hat is inside of this P minus 2 sigma to P plus 2 sigma, right? That's what we learned in the previous sections, right? Do you have any question at this time? Is it clear? Good. Then, now also you need to think a little bit more. Then, actually it is the same thing saying that from here, instead of this one, because we don't know what the P is and we don't know what the sigma is, instead of this one, we can think about your just chosen P hat, then you can just get some interval, which is P hat minus 2 sigma, P hat plus 2 sigma, right? So for example, if your P hat is chosen by here, maybe your P hat is in here, this is our mean P, then you can actually the same, this interval, you can just move the interval P minus 2 sigma to P plus 2 sigma into the interval from here to here, right? P hat plus 2 sigma and P hat minus 2 sigma, right? Can you see? So what I did is I just moved the interval, yeah, which is from minus 2 sigma to 2 sigma, is just moving in the left, so that the center of the interval should be P hat, which we chosen, and then we just thinking about this interval instead of the minus 2 sigma to 2 sigma, right? This is because we don't know P, but we only know P hat, right? Okay, yes, correct. Thank you, Flora. Then, also what statistician found is that sigma is determined by P, but it is very similar to using P hat. So that's what statistician also found, is that actually we say that P sigma is actually determined by P, but actually you can calculate sigma using P hat again, right? So you can use this value on here to get this interval, right? Then again, when you get this interval, it contains P by 95% probability. Okay, question? How do you know, how can we add a software? So we need to choose both. Yes, because we want to get some interval that we are sure that our P is inside of here, right? So that's why we choose the two numbers, minus 2 sigma and plus 2 sigma. Okay. Does it make sense? So this is a little bit tricky part. So actually the statement, this one, that P hat minus 2 sigma, P hat plus 2 sigma contains P by 95% probability is the same as P hat is actually true by 95% of probability. P hat should be inside of this 2 sigma interval. Can you see it? Because yeah, if your P hat is in this, in the green interval, then definitely this interval, the red interval, always contain P because the distance between P hat to P is actually smaller than sigma, right? 2 sigma, right? And then that's what we call confidence interval. And that's why people say that in the P should be in the confidence interval by probability, by 95% probability. Right? Okay, do you have any question in this? So if you understand this picture, then the rest of it is just nothing but applying this picture. So yeah, this is the most important, logic. So, and most difficult logic you can follow. So for example, if you want change this 95% with 99.7, then what we need to change? 2 to 3, right? Because we are in here, if you just want to say 99.7 instead of 95%, you can just change 2 with 3 to get 99.7, right? Here, everything is 2. Every 2 should be changed to 3 to get 99.7%. And again, maybe you don't want it, but if you just change it with 68%, then what you need to do is actually change 3 with 1, right? So it depends on what kind of confidence you want, right? If you want more confidence than 95%, so if you want confidence 99.7%, then you can choose interval a little bit bigger than before, right? So what a little bit bigger is just minus 3 sigma to 3 sigma. Then you can get, you can say that in 99.7% of probability, the P should be inside of this interval, right? So what we want to do is actually just approximate P more precisely. That instead of just claiming that P hat is equal to P, we just say that P is actually inside of this interval, small interval, not just some random value in the infinite number, but inside of it in small interval, right? That's what we want to say. Okay, does it make sense? Do you have any question on this? Okay, then let's deal with some problems. So that we can apply this one. Here, the margin of error is called this 2 sigma, right? So here is 2 sigma. So it is just this formula. So let's deal with the example 8.3. Suppose a study was done on random sample of 500 voters, and 55% says that they would vote for party X, right? And we want to construct a 95% of the, okay. 95% confidence interval for actual percentage of adult voters who would vote for party X, right? What is the margin of error? So in this case, actually we know that this 500 is the sample size. It is just sample size. And this 55% is proportion of the sample. Okay, two questions. No, in this case, usually I just provide that please use the 68, 95, 99.7% rule.
So it'll say it in the problem.
Yes, yeah, it is in the program. Yes. So what her ask is that do we need to use the exact number 68 point something or just use 68? And I will provide it in the in the program, so you don't need to worry about it. Yeah. So good question. Great. Okay. So in this case, a p hat is 55%, which is just proportion in sample. Then what we want to do is construct a 95% confidence interval, right? And to deal with this, as I said, confidence interval is just nothing but PM minus 2 sigma, because we have 95 confidence interval. But if it requires 99.7% confidence interval, then you need to use 3 instead of 2. So here, this and this 2 is 2 because the program requires 95%, right? And but sigma is square root of p times 1 minus p over n, but we don't know phi, right? So instead, you can use p hat because we know p hat over n. So here p hat is 55% and n is 500, so (0.55 times 1 minus 0.55 over 500 with square root. And if you just calculate this with your calculator, then what you can get is 0.02224 something. Yeah. So using this number, then what you can get here is, okay, question? Yes, we didn't multiply it because the program requires you to find margin of error, right? So that's why, yeah, I just used the number instead of the, actually that number, 500 is reflected in the standard deviation. And that's the reason why we just do it. Okay. A good question, yes. So here, using this, you can put it in here. Then what you can get is, it is just 0.55 minus 2 times 0.0224 0.0224 and 0.55 plus 2 times 0.02224. So here, if you calculate this, then what you can get is 0.5044 to 555. Okay, I just calculated right now. 0.04448 and 25545. Okay, 54554. So, yes, so just, yeah, in the exam, I will definitely encourage you to just round up at some point. So definitely I do not require you the exact answers, so do not worry about it because I'm not good at this also. So it is almost 0.5455 to 0. And if you add this number, then 0.5944 or 45. That's it. So this is exact confidence interval that you can assure that actually P should be inside of here in this confidence interval by 95% probability. Yes? Okay. Yes, if you don't have P, then you need to use P hat. But if you have P, then you need to use P instead of P hat, right? That's a good question. Okay. Yeah, just same formula, but different P or P hat. So when you have P, then use P. But if you don't know P, then use P hat instead. Okay. Oh, same. Okay, great. Oh, pardon. Mm-hmm. Oh no, it's not P half, but P hat. That's what I say. Yes, so P hat. So this one. Yeah. Great. Okay, yeah, and Pora says that will you let us know how many decimal places to round it to? Yes, definitely. In user questions, I definitely mention that how many decimal places. Or if you are not sure, then just use the square root rotation. Then I definitely accept it as your answer. So you don't need to worry too much about the expressions. Yeah. Usually I hate to just delete the points because of the approximation is not true. So don't worry about that too much. Okay, so is there any other question for the example 8.3? Okay. Mm-hmm. 0.505. Oh, you mean this part? Here? Other one. Oh, okay. 0.5055. Oh, thank you. Sorry. Yeah, I'm not good at math. So, okay. Yeah. Ah, yes. So actually, I write down 5055 in my answers, but yeah. Okay. Thank you very much. Okay, great. Thank you. Okay. Do you have any other question? Great. Then let's deal with the next example. So a random sample of 200 people found that 25% of them small, and construct a 95% confidence interval for the actual percentage of adults who small, right? And here, what is the margin of, oh, yeah, in the previous example, margin of error is just 2 times sigma, so it should be, this one is margin of error, and it should be 0.04448, right? Sorry. That's the margin of error. So again, here it is the same. So now our n is 200. And from this random sample, we know that 25% actually smokes. So p hat should be 0.25. And now we want to construct a 25% confidence interval. So this 25 confidence interval is p hat minus sigma, 2 sigma, comma p hat plus 2 sigma. But again, we want to calculate sigma, but we don't have p, right? So instead, you can use. Yes. Okay. So instead, we can use the same formula with p hat, which is 0.25. So here it is square root of 0.25 times 0.75 over 200. And if you calculate it using your calculator, then it is almost 0.061237 something. So here, margin of error is just this 2 sigma. So this 2 times 0.061237. So it should be 0.1224674. And the confidence interval is just 0.25 minus this margin of error, 0.1224 something, 0.25 plus 24 something. So it should be 6, 7, 2, 1. Okay, question. Standard deviation. 0.0306 for this one. Let's support this example 8.4. Oh yes. So, but what I did is actually multiplied. Ah, you're right. Yeah, it is actually multiplied number. Sorry. Yeah. What Dawson found is that actually this number is what I write down is multiplied. So it should be, sorry, yeah, 0.0306, right? Thank you, Dawson. Yeah, then margin of error is just multiplying 0.0306. So yeah. So it should be now 0.061237. So yeah, actually that's the, oh, no, what? Okay, yeah. 0. Yeah, just write down, yeah, 0.0612. So in that case, so 0.25 minus 0.0612, 0.25 plus 0.612. Okay, just delete this one. Then if you calculate it, then when you get is 0.1888 and 0.3112 something. So this is our confidence interval. %. Thank you. Okay, do you have any other question? Good. So margin of error, yeah, it's just 2 times sigma. Yeah. Yes, 0.0612, yes. So here is margin of error. So actually it also depends on the rate of confidence interval. So in case of 95% survey, it should be 2 sigma. But in case of 99.7% confidence level, it should be 3 sigma, right? So I just write down it here. If the program requires to find 99.7% confidence interval, then margin of error is just 3 times sigma, right? Okay, sigma is not 6 sigma. So be careful about the, usually I will require to ask about the 95% confidence level, but when you see the 99.7 confidence level, the margin of error is a little bit bigger than the in case of 95%. Question, okay. Do you have any other question? Great, then let's move on to example 8.5. So in case of example 8.5, if the 95% confidence interval for some parameter is determined to be from 42% to 46%, what is the margin of error? So here we know that this confidence interval is nothing but p hat minus 2 sigma, because we are doing 95% rate. So, and p hat plus 2 sigma. And from given information, this one is just 0.42, and this one is 0.46, right? And margin of error is just 2 times sigma at this, in this case, right? So if you just add those two numbers, which is 0.88, it is the same as p hat minus 2 sigma plus p hat plus 2 sigma. So it is just 2 times p hat, right? Okay, question? Oh, yes. So you need to know why this equation happened, right? Because actually it is the definition of confidence interval, so you need to know about this equation. Okay. Okay, right. So here, this 0.42 is p hat minus 2 sigma, and 0.46 is p hat plus 2 sigma. So by adding this, what you can get is just 2 p hat, because 2 sigmas are just canceled out, right? So from here, 2 p hat is 0.88. So p hat is 0.44. Then you notice that now by p hat plus 2 sigma minus p hat is 2 sigma. That's margin of error. And we know that p hat plus 2 sigma is just 0.46, and p hat is just 0.44. So if you just subtract these two numbers, then what you can get is 0.02, right? So margin of error is 0.02 or 2%. So. Okay, do you have any question? So as Grace pointed out, Grace, right? Okay, so as Grace pointed out, please remember this equation, because it is just nothing but definition of the confidence level or confidence interval with 95%, sorry, yeah, 95%. It is just definition of confidence intervals, so definitely you need to know it. Okay, do you have any question? Good. Okay, next question is, what is the formula for approximating 99.7% confidence interval for P? So in this case, it is, again, when I said if you need to get 99.7% confidence interval, then you need to use 3 instead of 2. So it should be p hat minus 2 sigma and p hat, 3 sigma, thank you, plus 3 sigma. And also we know that sigma is actually approximately the same as p hat square root of, p hat times 1 minus p hat over n, right? So this is the, as I said, this is the definition of confidence interval, and sigma is approximated with p hat. So, hey, David asks me, can you explain why 3.6? Oh, no, it is not 3.6. It is 3 sigma. Sorry, I always a little bit difficult to writing down sigma, but yeah. And the number 3 is came from here. So when you see the nomad curve, and what we use for 95% is 2 sigma, right? And this is because from 2 sigma to 2 sigma takes 95%, right? Approximately. And when you use 3 sigmas for each side, then it takes up 99.7%. Then that's why we use 3 instead of 2, right? Does it make sense, David? Great, yes. So technically, we already use 95% and 99.7% because those are the two numbers we are familiar with, and we do not use any other numbers usually. Okay. Do you have any other question? Okay, and Karen said, when confidence interval is 95%, you use 2 sigma, and when confidence interval is 99.7%, you use 3 sigma. Yeah, that's correct. Yes. So example 8.7, a national poll asks 2,100 others whether they were satisfied with their jobs, and 1040 of them said they were, and construct a 99.7% confidence interval for actual percentage, right? Who are satisfied with their job. So in this case, the sample size is 20, 100. And here P hat is the percent where they were satisfied with their jobs. So it is temporary over 20, 50, 100. So if you calculate it, it is 0.416 or 41.6%, 0.6%. And here, since it requires us to use 99.7% confidence interval, so here what we need to do is confidence interval is p hat minus 3 sigma p hat plus 3 sigma. So margin of error is 3 times sigma. And we know that sigma should be calculated with p hat square root 0.416 times 0.584, which is just 1 minus p hat, over 2500. Then again, if using the the calculator, then what you can get is 0.00987 something. So here 3 times sigma is just 3 times this number, and what you can get is 0.0295736 something. So the confidence interval is also, if you just calculate it, then approximately it is just 0.3864 to 0.4456. So again, it means that by the 99.7% of probability, the actual percentage among all others who are satisfied with your job is in between 38% to 44%, right? Great. Bless you. Do you have any question? Okay, let's deal with the, I think it is the last question. So, okay, so survey will be done to determine if young adults read novels. And 60% of all young adults do read novels. Then determine the minimum number of people to be surveyed so that the margin of error will be 3%, assuming we want the 95% confidence interval. So in case of 95% confidence interval, margin of error is 2 sigma, right? And this one wants to get this 2 sigma should be 0.03, which is 3%, right? Oh, Joanna actually asked that are 0.416 and 0.584 supposed to be multiplied? Yeah, what's on the scale? Yeah, yes, you need to multiply. Yes, this should be multiplied. Okay. So, okay, I'll go back to this one. So we know that we want that this 2 sigma is equal to 0.03. And at this point, actually this survey are not done, right? But instead, we know that the portion of all young adults to read novels, right? So in this case, we know P by assumption, which is 0.6 from here, right? So it's different with other ones. So in this case, we know P, therefore we can directly calculate what the sigma is. Okay. So in this case, we can use P, which is 0.6 times 0.4 over n, right? But we don't know n, right? But that's actually what we want to know, because to determine the minimum number of people to be surveyed, so that's what we want to know about the n. And we know that actually 2 times sigma is equal to 0.03, right? So you know everything in this equation but n, right? So it means that you can actually get the n. So by divide both sides by 2, what you can get is 0.6 times 0.4 over n is 0.015. And you can scale both sides, then 0.6 times 0.4 over n is square of 0.015, but this is 0.000225, and 0.6 times 0.4 is actually 0.24. So 0.24 is 0.00225 times n. So by dividing both sides by 0.00225, you can get what the n is. Oh, sorry, what I done. That's not what I want. I deleted everything. So, okay. So let's delete this again. Sorry. Scale. Then this is 0.000225. So here 0.24 is equal to 0.000225 times n. So 0.24 divided by 0.000225 is equal to n. And if you just this division using your calculator, then what you can get is, it is almost 1,066.666 something. So you need at least minimum 1,067 people is needed, right? Because we cannot divide a person. Should be sampled, right? At least. So here, what we did is using the sigma and its formula, and just example gives us what the P is. Then you can know what the N is with the specified margin of error, which is just nothing but 2 sigma. Then you can figure out that how many sample size needed to get some specific margin of error, right? So that's the thing we use, and usually in the actual poll, this kind of expectation is very important because if you just ask about kind of the survey company about doing a 1,000 people polling, then it takes at least $100 to $1,000. So it is very important program when you determine the sample to minimize your cost. Okay, do you have any other question? Good. Then let's deal with some review question. Yeah, so, okay, I will do reviews solve some review question here. And I plan to give a review on Sunday, 2 p.m. as usual. So I hope that you can attend it, but if you don't attend it, then definitely I review, update the lectures on the eCampus so you can review it after Sunday. So these are actually programs I just wrote down based on the draft of the exam 2. So if you know how to solve it in the review program, then I think that there is no problem to solve it the actual exams. So first program is, sorry for my bad writing. So match scatter plot with correlations, right? So the first one says that number A, it is very sparse, right? So maybe A is matched with 0 because there's no relationship. So let's just be in the radar because we don't know it yet. But in case of F, it is clear that the relation is linear in different section in the left bottom side, right? So in that case, the slope is negative. And it is very strong, so maybe F will match it with A, correlation minus 0.99. And number E, maybe this one is matched with small f because the other one with positive slope is C, but instead of C, E is much more closer to each point, right? So in that case, definitely E, F is 0.9 is for E, and 0.5 is for C. And next one, maybe you can just compare D and B to determine whether which one is C, 0.7, minus 0.7, or minus 0.3. But in this case, B is much more sparse, right? But D is much more consistent. So maybe D should be negative 0.3, and B should be, just negative 0.7 correlation, right? So in this kind of program, it is important to just get some intuition about from this pairs of data or from you can get in-person correlations, right? So usually if your intuition says that it has correlation, then it's true. Okay. Question? Yeah, more sparse than, yes, sorry, thank you. Yeah, because if it is more sparse, then it should be close to 0, right? So the sign is only for the direction, not the sparseness. So if it is more consistent, then it is close to 1, but or 1, 1, minus 1, but it is more sparse, then it should be close to 0. Thank you. Katie? Yes, thank you. Yeah. Okay, do you have any question on this program? Okay, good. And David, next one. So if your scatter looks like below, so it looks like circle, right? Those points actually form a circle. Then what is the possible correlation? 0, right? Because even if it has some kind of form circle, but every point are actually spread in different ones, so there is definitely no linear relationship, right? So that's why the question is 0. And one thing I want to mention in here is that even if your data has some form, but your correlation may be 0, right? Because correlation only measures about the linear relationship, nothing but, if relation is kind of circle or quadratic, then it may be 0, right? So that's the point of this question. And next is about this regression line. So this regression line came from this violet point. And according to this regression line, when x is equal to 0, sorry, this is 0, then what is the predicted y according to this regression line? Near minus 100, right? So maybe y is just near minus 100, right? So this point. And if these violet points are all data we use to get this regression line, what types of prediction made in part A? Can you remember the extrapolation? Great. So it is extrapolation. And yeah, so if you just import those points, those green points, then it is interpolation. But if you just choose this red point outside of your data, then it is extrapolation, right? And yeah, sorry for bad writing. Why extrapolation is not good? Pardon? Yeah, it can't be exact because sometimes, yeah, data, since data are missing, data is missing, it's not exact, right? Yeah, because it's just an estimate, right? Because we don't know actual data among there. Okay, thank you, Karen and Catherine. So, and next one is which of the given survey methods best describe the survey in the following scenario, right? So HEB wants to know which food the customer prefer the best. Hence, it just asks all employees of the company about it. And there are choices. First one is voluntary response sample. Second one is convenience sample. And third one is non-response. Which one? 2, right? Because it definitely we don't know whether it has voluntary response sample or not, but also we don't know whether there is non-response or not. But the one thing sure is that they just ask us about their employees, which is there for convenience, right? If they really want to get the customers, then they need to use other methods, like using the survey company, or just ask customer for when they purchase something or something like that, but they use just their employees. So it is definitely an example of convenience sample. And the what effects make us to use double-blind experiment when you test new medicine? Placebo effect, right? So I just want you to recall that, yeah, placebo effects occur when the subject knows that actually we will do some experiment, right? So in that case, actually that information changes on the subject. So it is a little bit difficult to measure what kind of actual effect happens for each given treatment, right? So double-blind test, double-blind experiment is something that subject, not subject nor, yeah, no observers, no each, who is in control group or who is in control group or who is in, sorry, I should be one. Who is in treated group. Treated group means that group having treatment. So that's the double-blind experiment. So it is kind of experiment that not subject nor observer knows who is in control group or who is in treated group, right? And that's usually for preventing placebo effects, which means that subjects may changes when they know they treated by some experiment, right? Okay, so if you have no more question, then I will do much more examples in the review session in the Sundays. So please let me know, and let's call it a day. Thank you very much. And if you have any question, please let me know. Okay, and good luck for exam 2.
Could you go back to example 8.5 from the notes?
Number 5?
8.5.
8.5, okay. Give me a second, 8.5. Oh, yes.
So I understand up to the point like where we got the 2 p head and then we divided it and got the 0.44, but after that, what was the reasoning behind the formula for like the subtracting the 0.46, the 0.44? How did you get to that?
So the reason is that actually what we know is PF plus 2 sigma and PM minus 2 sigma, right? And from this, we can know that what is P hat, right?
Yes.
But what we really want to know is margin of error, and which is just 2 sigma, right?
Right.
So to get this 2 sigma, I just subtract this P hat from PF plus 2 sigma, right? Then the only remaining one is 2 sigma. So
okay.
That's why I counted, yeah.
Okay, gotcha. That makes sense. Thanks.
Thank you. Okay, question? Yeah.
Like this was like from earlier in the notes.
Okay.
You know how for this, the charts and stuff, it says if you reach the end of the line without enough digits for your label, ignore the end of the row and continue with the next line. But like when you did this example, you didn't ignore 5. And so I did it again, and this was supposed to be the numbers that we were trying to get.
You are right. That's what I actually explained wrong.
So I was like, I don't know, maybe for the exam, like I didn't know if you wanted us to add the end of the line or if you just want us to ignore the number
So,
at the end of the line.
Yeah, in the exam, I will definitely get rid of this kind of cases that here.
Okay.
Yeah,
and then
but
just start over here.
Start over here. Yes, right.
Okay.
But thank you very much.
No,
Let me know. Yes. So,
thank
thank
you.
you. Yeah, I will definitely fix it. Yeah. Thank you. Okay. Do you have any other question in the Zoom, people? Then I will end the session, and thank you very much for hearing, and see you next week.